Hi guys, Ryan here from Elite Diagnostic Solutions. Just doing a quick video for you, showing you the sensor simulator. There's a few different functions that I wanted to show you guys. So at the moment, we are producing a sine wave. What we can do is we can obviously change the frequency if we like. A bit of glare there, so if you want to change, go up the frequency. See if I can get you both in the shot at the same time. So we'll go up the frequency. And as you can see, frequency increases. We can go down with the frequency, change the output pulses. As you can see, they get further and further apart. This would be good for testing ABS sensors, inductive ABS sensors. So what we can do is pause it, go back. We can change obviously our offset. So at the moment we're 0 to 5. We can take it to 0 to 12 if we like. You can see it reacting accordingly. We can also bring down the offset so we can go from 4 to 12, for example. As you can see, we're now minus 4 to 12. Another cool function, if we go back and back again, we have a load of different option menus. We have obviously square wave, sine wave, triangle and sawtooth patterns. If we go into the square wave generator, and you can see it outputting there. Again, we have voltage peak, so we can change this accordingly. So say we wanted a 0 to 12 volt square wave, we can have that there. We can also change the offset again, so if we wanted a 4 volt to 12 volt square wave, again we can change that there. So drastic changes you can make, all sorts of different sine waves and signals. With this one, frequency, we can obviously increase the frequency, so we increase the amount of signals on the page, as you can see there. .900 hertz, so 9,000 hertz signal. We'll stop that. Obviously we can change the duty cycle as well if we like. So come back out of there, back out of there. We'll go into DC output, so this is where we can obviously send a DC signal into that. Currently we're at 0 volts. If we like, we can change it to whatever we like. We're into a 1/10 of a volt, so we go to up to 5. That's 5 volts, as displayed on the tool. We can change it then 100ths of a volt. So we're now at 5.5 volts. And if we wanted to get really technical, depending on the signal we needed to produce, or the output of the voltage we needed to produce, we can change the 1/10 of a volt. So we're now at 5.5 volts on the screen. And you can see how crystal clear the output is. There's no noise to it. It's a real good, nice power, DC power supply. It will go all the way up to 12 volts battery voltage. Maximum output voltage, DC output, 12 volts. We go back. We do have a pulse option. So this will send SOUT, stands for signal out pulse, or you can do a power out pulse. So what it can basically do is it can send a power output using the output of the driver, which is 4 amps maximum output on this mode, or we can do a signal output, which obviously only sends a maximum of 150 milliamps output. So we can go into this one. Pulses count 10, 5 volts, passive level, active time, how long we want it to go on for. Obviously we can change that to 100, whatever we fancy, 111 milliseconds is that. Turn that one off. 11, that'll be 11 seconds, 0.0 milliseconds. So passive time, so we'll set that to 10. And we'll click start. Then as you go, click start again. As you can see, so we can produce signals according to what we want. Every time I press the start button, you'll see the signal being produced on the screen. So start, start, start. Again, so really handy depending on the signal you want to produce. I mean, you can produce so many different types of signals with this tool. But completely up to, obviously, you know, your mind, I suppose. It is literally amazing the amount of stuff that you can produce with this tool. We'll go back out of there. There's so many different variations you can do. And back out again. And then into power sim, like I say, is the DC output driver, which we showed the other day. We do have DC output, which we went into, sensor sim, and these are presets. So there's 3 presets in this one. So you got a CKP, current position sensor, a Lambda sensor, and a KS knock sensor. So if we go into the CKP, we can change 2 different types. So we've got inductive, and we have inductive rectangular and a CKP Hall effect sensor. So if we go inductive, we can change the amount of teeth. So 58 teeth, missing 2, amplitude 0 to 8 volts, that will be. RPM will be 900 RPM. So then we can set that, and as you can see, the trigger mark in the middle. Again, you can change you can either change the amount of teeth, you know, how many missing, amplitude. So if you wanted 0 to, if we go down to 6, so 0 to 6. Then if we keep going down, again, depending on what we actually want to produce. And then again, we can bring the signal offset up if we like, or up, yeah, so go up with that one. As you can see, it changes the offset. See the signal moving up and down. So we can go plus or minus with that. And then obviously we can change the RPM if we like. So we'll go back out of there, back out of there. Obviously we have a Lambda sensor if we want to produce a Lambda sensor. 2 different types, zirconia or titania. And then here we go, we can see it producing this will be a 200 millivolts to 0.8 volts change. So if we zoomed out of the scope, quickly just chuck you on a scope, and because we're 50 seconds time base at the moment, so we'll come out and we'll change it to a 10-second time base. Should probably do it. You can see it nicely there. We'll change our voltage down from a 20 volt scale, change it down to 1 volt, and we should see a nice oxygen sensor signal being produced. And what we can do is we can change the period of the transitions. So what we can do is we can go we can go up with the transitions. That's maximum. We can go down with the transitions, so the signal is a lot quicker. Slower. Back down again. As you can see, the signal gets quicker. And then down to a lean volt. So we can produce rich and lean conditions. So this one obviously switching nicely. Really slow. Really slow again. And then we can go down and produce just a lean condition. So we can check for output, stuff like that. See if the sensor actually, if the ECU sees a lean voltage, does it correct the fuel trims, etc. Stuff like that. And again, really easy to switch this off, guys. We literally just hit the output control button. S out means signal out, just switch it off. That's it. Signal is now not producing anything. Again, guys, just a real quick overview of this tool. It literally has so many different capabilities and different signals you could produce. Pretty much, the possibilities are endless with this tool. There's so many different things you could bypass test and reproduce and use it for anything really. You know, from running EGR valves and motors to outputting sensor voltages to get the readings you're looking for on a scan tool, stuff like that. But I just wanted to show you it quickly, and as you can see, there's just so much in this tool that, you know, it's an incredible bit of kit. But yeah, that's all for me, guys. Thanks very much. Bye.